Trig identities. Go ahead and pause the video and copy these into your notes. And then here is a table of trig identities. Again, we're going to pause the video to copy these into your notes. I'm looking at the video screen. It might be a little hard to tell down here at the bottom, so let me point a couple things out. Each of these variables is a U as I go the whole way down the page. So I've got a U, a U, a U, a U. And then the only other thing, and I think you can see this pretty well, is we've got pi here. So go ahead and pause the video and copy these down into your notes. All right, so what are we doing here? We are verifying trig identities. These are useful for converting a trig expression. So we're taking a trig expression and we're putting it into a more useful form algebraically. And we're verifying, which means we can't assume the two sides are equal. The whole purpose is to see whether the two sides are equal or not. So when we do this, we're going to be using our table that you just copied into your notes. So keep that table handy. I'm going to do a few examples here. So example 1, this is going to be verify the identity. All right, so I need to verify if secant squared theta minus 1 over secant squared theta equals sine squared theta. So I'm always going to take the more difficult side of the equation first. So I'm going to completely leave this side alone, and I'm going to take this side only, and I'm going to write this side again down here just to make it abundantly clear what I'm doing here. And I'm going to work through this side of the equation, trying to make this side of the equation equal to sine squared theta. All right. So the first thing that I need to do is look at my table of trig identities and see if there are any of them that I can use. And the one that really kind of stands out is the Pythagorean identity. So the Pythagorean identity, 1 plus tangent squared u, which is going to be theta in this case, equals secant squared u. All right. So by doing this, I'm going to plug in 1 plus tangent squared u, well, theta, again, in this point, because my variable now is theta, in the numerator. So secant squared theta minus 1 over secant squared theta then is going to equal 1 plus tangent squared theta minus 1 over secant squared theta. Okay? So plus 1 minus 1, those two are going to go away. And so this gives me tangent squared theta over secant squared theta. All right, that's just plain old simplifying. All right, now we're going to use the reciprocal identity. So 1 over secant squared theta is equal to cosine squared theta. And we've been using this one for a couple of days now. So now again, I'm going to plug this in because, mind you, I really have tangent squared theta times 1 over secant squared theta if I separate that fraction. So that's going to become tangent squared theta cosine squared theta. So I just used this identity, the reciprocal identity, and I plugged in cosine where 1 over secant squared was. Okay, so the next thing I'm going to do is use the quotient identity. So the quotient identity is going to, so let me write that out for you. So this is tangent theta equals sine theta over cosine theta. Let me make sure that's on the screen. Okay, good. All right. So instead of having tangent theta right here, I'm going to plug in sine theta over cosine theta, and I still have the cosine, squared. Oh my goodness, I lost my squares. Let me put my squares in. Okay. All right, there we go. I lost my squares over here, put my squares in. And the reason I'm putting my squares in is because I'm working with squared functions in this particular problem. Okay, so now cosine squared cancels out, and I have sine squared theta. So guess what? Sine squared theta equals sine squared theta. So I have verified this identity. Okay, let me do a second one. So example number 2. So for this one, I'm going to verify the identity. Secant squared a equals 1 over 1 minus sine a plus 1 over 1 plus sine a. All right. Okay. Again, I'm going to work with the more difficult side of the equation. So just to be 100% clear, I'm going to start down here, and this is the only part I'm working with. All right. So the first thing I'm going to do is add my fractions to simplify this side of the equation as much as I can. I need to make a common denominator. So I'm going to multiply this fraction by 1 minus sine a over 1 minus sine a. And then I'm going to multiply this side over 1 plus sine a. 1 plus sine a. All right, there we go. So now I have a common denominator. I have 1 plus sine a plus 1 minus sine a. And all of that is over 1 plus sine a times 1 minus sine a. Okay, I'm going to simplify again. So moving down here. Now I have 1 plus 1, which is 2, and positive sine a and negative sine a, so that's going to give me 0. And on the bottom, I have a difference of squares down here. So I'm going to take this difference of squares and write it as such. So that's going to be 1 minus sine squared a. Okay, so I just did some pretty simple algebra simplification. There we go. All right, the next thing I'm going to do is use the Pythagorean identity. So if you recall, or if you want to look on your notes here, the Pythagorean identity, the one that we're going to use, and I'm going to kind of write it off to the side here because I don't want to confuse my work. Let's write it over here so I can move it out of the way just so we don't get confused. All right, so sine squared a plus cosine squared a equals 1. So that means that cosine squared a equals 1 minus sine squared a. And I know that cosine is related to secant by the reciprocal identity. So that's what's causing me to travel along this path. I'm working on getting to secant squared. All right, so I'm going to plug this in, and then I'm going to move this paper out of the way. So this becomes 2 over cosine squared a because of the Pythagorean identity. All right, let me move that out of the way. So now I have 2 over cosine squared a, And I know, I'm going for secant here, I know that the inverse of cosine squared A is secant. So again, just to be 100% clear, I'm going to write this as a separate fraction. This is equivalent. I'm just pulling it apart. And so since cosine squared A is the reciprocal of secant squared A, I'm going to fill it in secant squared A. And so now I have verified this identity. I have made the two sides equivalent. Okay. Next example problem here. So example 3. For this one, I'm going to verify the identity tangent squared x plus 1 times cosine squared x minus 1 equals negative tangent squared x. Okay, and again, I'm going to use the more difficult side of the equation and attempt to make it negative tangent squared x. So I'm just taking this side, I'm going to rewrite tangent squared x plus 1 cosine squared x minus 1. All right, so I need to, as soon as I see this plus 1 minus 1, that's when I'm looking at my Pythagorean identities. So tangent squared plus 1, if you look at your Pythagorean identities, I'm not going to write it this time, look at your Pythagorean identities, and 1 plus tangent squared u equals secant squared u. So I'm going to go ahead and replace 1 plus tangent squared u with secant squared u, but in this case it's x. So this is going to become secant squared x. Okay, and then we did this just a minute ago, except for we're going to rearrange it differently this time. So I have my original, so this is what we used, this is the rearrangement we used the last time. So I'm going to take my original and I'm going to move it around here. So I'm going to move the 1 to this side. So I've got sine squared a plus cosine squared a minus 1 equals 0. And then cosine squared a minus 1 equals sine squared a. Excuse me, negative, there we go, sine squared a. Okay, now remember, we're going to take this and we're going to replace it with the negative sine squared a, but of course our variable in our current problem is x. So negative sine squared x. So that was using the Pythagorean identity. All right, now I'm looking at this and I'm trying to figure out how to get it to tangent. And I know from the quotient identity that tangent u equals sine u over cosine u, and I'm going to use it in its squared form. So if I can just get this to end up being sine squared over cosine squared, I'll be in good shape. Well, lucky for me, I can use the reciprocal identity because I know that secant squared is the same as 1 over cosine squared. So I'm going to take this secant squared x and I'm going to make it 1 over cosine squared x. All right, and then I'm going to simplify. Okay, and then I know that, like we were saying just a minute ago, I know that sine squared x over cosine squared x is going to be tangent squared x. And again, I have verified my identity. Okay, next is example problem. So this is example problem number 4.